Good morning, everyone, and welcome to today's webinar, Energy Efficient Lighting. So before we get started, I just want to go over a couple things. So first, you've all joined in listen-only mode, but you'll have the opportunity to submit your questions throughout the presentation by typing them into the questions pane of the control panel. So you can do this at any time during the presentation, and we will collect these questions and address them during the Q&A session at the end. We'll also be sending around the slides to everyone after the presentation. So now I'd like to introduce our speaker today, James Dunlop from the Carbon Trust.
Thanks, Susan. Good morning, ladies and gentlemen. My name's James Dunlop. I'm a senior engineer with the Carbon Trust. Over the past few years, I've been involved with the Green Business Fund and have seen a lot of lighting projects come through the scheme and come through to implementation. With the good opportunities that are provided with LED lighting. In today's webinar, we're going to look at the importance of good lighting. We're going to look at traditional lighting options that are still out there and typically benefit from replacement with LED. We'll also look at the benefits of switching to LED lighting and look at some other considerations around that, as well as talking further about the Green Business Fund itself. So just to give you a bit of background on the Carbon Trust, we're a not-for-profit organisation with a mission to accelerate the move to a sustainable low-carbon economy. We provide that in three ways. Firstly, through advice to business, governments and the public sector, such as the Green Business Fund for SMEs. We also provide footprinting to measure and certify the environmental footprint of organisations and also products and services. And we also help to develop and deploy low carbon technologies and solutions. So with today's focus on lighting, as I say, we're going to look at what constitutes good lighting and we're going to look at the benefits of LED technology. And what we've typically found through the GBF scheme is that converting to LED tends to reduce lighting costs by 70%. So there's a massive step change in terms of energy savings from LED lighting in comparison to conventional. And I suppose lighting is pretty much ubiquitous across all industries, across all sectors, and for businesses large and small. You can see here on this chart an indication of the percentage of site electricity that is used for lighting. So places like warehouses at the top there, you can see would utilize as much as 90% of their electricity on lighting solutions, certainly with conventional lighting in place. And then of course it varies across the rest of the sectors, but it is a significant factor in all organizations, including larger industrial facilities, which may have some other energy intensive processes as well. So in terms of good lighting, what makes good lighting? Well, it has a range of impacts and it matters in terms of health and well-being, in terms of providing the right illumination level, both for comfort and for safety. Light color is important and the feel of a space is important based on the color temperature of the lighting. Color rendering and the ability to see colors accurately is also important. Minimizing glare, and of course, I suppose the main reason why we're looking at it today, the cost, energy, and carbon savings that come with it. So lighting does impact on our alertness and on our well-being. It can significantly influence people's activity, and that comes through from the circadian rhythm that you can see there. So basically, people's sense of well-being are impacted by the lighting levels, and it can certainly have a positive impact on health, and is something that has been looked at closely in new healthcare facilities in particular. It also impacts on our ability to work accurately. You can see here in this chart, level of errors can reduce and potentially work rate can increase depending on light level. With work rate, it's important to note that there's a plateau there at a certain level once you get above in around 500 lux in that case. And the level of illumination overall is important. So there's no point in overlighting spaces. It is important to have high levels of illumination where visual tasks are difficult, such as assembly areas and places of that nature. But if you're dealing with other areas such as corridors or less frequently occupied spaces, much lower levels of illumination would be more appropriate. So you could come right down to 100 or 150 lux in comparison to lighting an office at in around 500 lux. So that's significant and will provide big savings even with LED lighting where a well-designed solution is put in place. Light color or color temperature is also important for the atmosphere of a space. In practical terms, it ranges from in around 800 Kelvin up to about 8,000 Kelvin, which is a very bluish light. So typically 6,500 is daylight. And when it comes to specifying a commercial solution for offices or for industry, you'll probably be in the range of 2,500, which would be a warm white, to about 4,500, which would be a coolish white. And again, it depends on what you're doing in the space as to what is most appropriate. In a hospitality environment, you'll want to bring that down to the lower end of the range to create the right ambience, and it may be in a laboratory setting or a more clinical environment, you'll want to go to the upper end of the range to provide a good clean white light. With regard to color rendering, this is something that LEDs are now very good at. You can see the impact in the pictures at the bottom of this image of sodium lighting, looking at fabric in daylight on the left and looking at it under a sodium light on the right. The color rendering changes significantly there, and it's very hard to make out color. So getting good color rendering is important. It effectively defines the ability of lighting to show colors, and RA100 would be ideal. So you'll want to specify lighting systems with a color rendering index of RA80 or greater, unless you have a particular need for good color rendering. In terms of illumination levels, you also want to avoid glare. So glare can be caused by excessive and uncontrolled brightness. So if you have a particularly high output light source which isn't well diffused, that can cause glare. So typically if you go to more points with less light in each individual point, it will start to reduce your glare levels. And this is specified under European standards under the Unified Glare Rating. You can see there that for offices, you'll want to have a figure of 19 or less, and you can get away with slightly higher figures whenever it comes to larger spaces such as in heavy industry, but typically you'll want to avoid glare, and good lighting suppliers will be able to give you those figures based on their designs. So I suppose that to summarize on what is effective lighting, the source is important, and we can typically see reductions in lighting power by as much as 80% simply by going to a low energy LED source. In addition to that, there's no point in running lighting unless it's actually required. So the use of presence detection sensors can switch it off when it's not needed, and the same thing applies to natural daylight. Where there is good levels of natural daylight, there's the opportunity to allow the system to sit back, to dim to lower levels, or to switch off altogether. And in combination of those measures, the typical projects that we would see are reducing lighting energy use by 70 to 80% through good use of improved light sources and of improved presence detection and daylight dimming. So just got an example here of one of our GBF projects. This was carried out by a building product specialist who replaced their lighting with low energy LEDs. You can see from the images there that they achieved improved color rendering. They achieved improved color temperature as well, and the environment was easier to work in with more appropriate illumination levels. So the LED solution reduced overall cost by 75% in this instance, and provided a return on investment in just over 2 years and 28 months. It also provided good savings around relamping with the longer life of the LED solutions. So looking now at what might be out there in terms of your own facilities, in terms of traditional lighting options, there's obviously quite a range of technology that has developed over a number of years. So you can see here on the chart, there's I suppose a time period dating back to 1780 there with oil lamps. Thomas Edison's invention of the filament lamp would have come in about 1880, and since then lighting has been developing. So incandescent lighting such as that with the filaments has been in place for well over 100 years, and the introduction of fluorescent lighting will have come through in the mid-20s with improvements to that. So it's really only since about the mid-1990s that LED has become more commercially available. And of course, we see now the phase out of incandescent lighting through EU regulation. So the incandescent tungsten filament lamp, it is still used extensively in homes and businesses. It's effectively phased out, but that's happened over recent years. There is still the availability of products, but they tend to be legacy stock or products that are designed for directional use, which is still permitted. So effectively, they have a very poor efficacy level. You can see there in this example, they're providing just 5 to 20 lumens per watt, which is very low whenever we come on to the other light sources. They do provide good color rendering, but they also provide very poor lamp life, which is why you would have to frequently replace the incandescent lamps. So if you have any of these in your business, it's absolutely worthwhile to make sure that they are replaced as soon as possible, and the level of saving is likely to be higher in this instance, in some cases approaching 90%, depending on the technology. So tungsten halogen lamps are an evolution of the incandescent lamp, which has halogen within the bulb to provide a slightly longer life and improved lamp light quality. So effectively they're slightly improving performance in this case, up to 15 to 24 lumens per watt, but still not brilliant. Tubular fluorescents, which again would be commonplace, are much more efficient than incandescent lamps. Their efficacy levels do vary depending on type. The older T12 and T8 tubes are less efficient, with the newer T5s improving on that and providing higher efficacy levels approaching the 100 sort of level. So in these instances, they do have better lamp hours, not necessarily as good as LED, but At the same time, there is good opportunities for savings by moving away from fluorescent to LED solutions. And compact fluorescent solutions, I suppose they were typically an energy saving solution in comparison to incandescent, but in many ways they have now been superseded by LED, and you'll see LED products available which can vastly improve on the performance of compact fluorescence. And they can be applied both as just a simple lamp replacement, or if you've got commercial lighting with compact fluorescent lamps in, it can be worth looking at a replacement luminaire. High pressure sodium that we use commonly outdoors, again, we point out the problem with the color rendering in this instance. It's worth looking at LED solutions. We're seeing more and more LED street lighting. I think in this instance, the specification of appropriate color temperatures and color rendering, along with a strong focus on glare issues, can provide a good solution which will provide significant savings. Metal halides too are commonly used. They have a reasonable lamp life, as you can see there. They have decent efficacy levels, again approaching 100 in some instances. One of the big disadvantages though is the restrike time. So once they're switched off, they take several minutes to come back on and come up to temperature. So the use of effective controls in terms of daylight dimming or presence detection are very limited in these instances. So it will be worth looking again to replace these with a well-controlled LED solution. And I've just got another case study at this point on a lighting replacement project that was carried out through the Green Business Fund. It's a company called TOT Shirts, and they have had a warehouse, a factory and office to light and to replace the lighting in. So effectively they were running relatively long hours in this case, operating 5,000 hours per annum, and they replaced their lighting at a cost of £36,000 with an annual saving of £18,000 a year, giving a payback period of in around 2 years. And in this case, their savings were in around 61%. So is that mix of metal halide and fluorescent, which was at a reasonable standard, led to that level of savings. But you can see there that the project payback was very attractive. And part of the reason for that, as we'll come on to later on, was the cost of the LED products. We would typically define cost in terms of the cost per kilowatt of LED. In this case, they had about 18 kilowatts of LED at a cost of £2,000 per kilowatt, which at that time was very competitive. Nowadays, that's becoming more and more commonplace. So it's worth looking at that for lighting projects to make sure that you're purchasing new products at a good price, which is a big influence on the payback. And I suppose the other aspect as well is it is very much horses for courses. So you will have different lighting solutions for different environments. So there will be quite a difference in that range depending on whether you're lighting an office, a retail space, or a warehouse. So in the next section, we'll just look at the benefits of switching to LED. As we saw from the previous section, there has been quite a shift in terms of efficacy levels, in terms of lighting performance over the years. All technologies have aimed to improve their efficiency and their efficacy levels. You can see there, incandescents have made incremental improvements over the years with the impact of tungsten halogen. Fluorescent technology too has reached a level and peaked. With LED, this chart, I suppose I've been using for some time now, probably for close to the last 10 years, but LED performance has gone on in leaps and bounds over recent years. So it is now well in excess of all other products that you can see there on the chart. So it has the highest efficiency and the longest life of widely used lighting types. It's a well-established technology now at this point, and again, it has seen significant price reductions in recent years. It's providing good color rendering capability and the opportunity for you to specify your own color temperature. That's now very well developed, so you can look at cool white or warm white solutions depending on what you're looking for. The efficacy is typically very good and often 150 lumens per watt plus. The lamp life in terms of hours is often stated in around 50,000, but can in many cases be greater. And also color rendering tends to be very good, and certainly 80 plus these days, if not well into the 90s. And I suppose it's important to note that there is continuing improvements to the efficacy levels. So there is more and more light for each unit of power coming from the LED solutions, and coupled with the cost reductions, it really does strengthen the case for moving to LED lighting in any areas that you haven't done already. And you can see some of that on the chart here. This is taken from Cree Lighting, who'd be one of the big LED chip manufacturers. It's important to note in this chart, it is a few years old, so it's from 2014, but you can see there that the lumen per watt levels that they're listing have got higher and higher over the years. Now these are laboratory figures, they're not design lumens. They wouldn't be directly comparable to the figures we've been looking at previously in the chart, but it certainly gives the indication that things have improved since LED technology became commonplace in around 2005, 2006 and beyond. So that has continued to improve over the years, and as well as that, we're now starting to see new developments in LED technology with organic LED now more commonly used. So as of this year, you would see that used very often in smartphones. It's a flexible, foldable solution, so it can be used in different ways than conventional LED. In terms of illuminating spaces, it's still in its infancy, but in the longer term, we could see organic LED solutions providing illumination for larger spaces, and perhaps done in a different way than your conventional luminaires that we have today. So looking then at the relative difference between a few technologies here, looking at warehouse and production lighting, you can see here the energy cost per luminaire per year for 3 different solutions. The one on the left is 400 watt metal halide solutions. So they would typically have a running cost of in around £385 per year for each fitting, and that's assuming that it needs to run continually within a production environment, perhaps with an electricity cost of 10 pence per unit and ballast losses of 10%. Compare that to T5 fluorescence, is 220 watt T5 fluorescence, which would have been a common replacement for metal halide solutions perhaps 5-10 years ago. They would typically have a running cost of in around £212 per fitting. The alternative in terms of LED would come down to a 150 watt LED, typically sometimes lower, to provide the same sort of level of light, and that would have a running cost of in around £130 per fitting per year. So it's a significant difference, even coming from T5 fluorescent, which is relatively efficient, down to LED. Looking at offices, the same principle would apply. Older T8 fluorescents, the example on the left there is twin 58 watt solutions would typically cost in around £50 to operate for a year, and that's based on operation 5 days a week, 12 hours per year. T5 solutions would be a slight improvement at in around £40 per year, and LED could provide that at closer to 20, and that's based on a 48 watt LED. Potentially that could be lower depending on the exact solution you're going for. And in terms of grid fittings, the figures are shown below, and you see a similar difference in terms of annual cost for T8 solutions, T5 solutions, and for a 30 watt LED panel. Again, the exact wattage of the panel that you might require for offices will vary depending on your layout and the level of lighting that you need, but 30 watts would be a fairly typical size. So taking a closer look now just at the impact of lighting cost. This chart looks at 4 different scenarios with 4 different costs of lighting. So in this instance, we're looking at a solution that will cost in around £1,500 per kilowatt on the left. So if you were to purchase lighting at that price, you'll typically see a payback period of 3 years, and this is based on an example where we're buying 10 kilowatts of lighting at a price that would range in this instance from about £15,000 up to about £30,000 in the right, and that will illuminate a space of in around 1,650 meters squared, so a typical sort of office size. We're basing this on lower operating hours, again looking at an office type environment in around 2,500 per year, using a unit rate for electricity of 12 pence per kilowatt hour, and we're assuming a reduction from the existing of 60% in terms of lighting power. So if you're to purchase lighting at £1,500 per kilowatt, you'll achieve a 3-year payback in this instance. At £2,000 per kilowatt, it'll be 4.5 years. At 2,500, 5.5, and at 3,000, it would be over 6.5 years. So I suppose there are a lot of instances where companies have upgraded their lighting in heavily utilized spaces, which makes good sense and is probably the most cost-effective area to look at, but have yet to upgrade their lighting in office areas and the likes. And I suppose that this chart hopefully would help in terms of looking at those decisions. So if you have had prices for lighting previously, they may well have been £3,000 per kilowatt or above, but the market price for LED has improved significantly, and what we've seen through the Green Business Fund has been a move in prices to 2,000 or below per kilowatt. Now again, not every luminaire is created equal, so again it's a balance as to what you need to light your space and what you're looking for in terms of the aesthetic. So it's useful always to go through a tender process just to make sure you're getting best value for money. Okay, we'll look finally then in this section at other considerations around lighting projects. So controls is probably the key one, and we've mentioned these already in terms of presence detection and daylight dimming. Time control can also be an effective catch-all, just to have external lighting, for example, switched off during the middle of the night. It may be required as people come and go from the building, but perhaps from midnight to 6 it can be switched off during the night, and the same would apply to office lighting. If you want to make sure that it's switched off, simple time controls can ensure that it's powered down at the end of the day. As well as that, the use of last person out switches can mean you've got a simple way to make sure that staff know how to switch off the lighting at the end of the day. and also for external lighting, the use of photocell control, just to make sure that lighting isn't coming on when it's not required and it's only on during the hours of darkness, will also provide good savings. And it may be the case that you've already upgraded to LED lighting, but didn't get the opportunity to introduce controls with it. There still is a case for going back to those projects, to looking at options for improving the lighting performance that you have by reducing operation. So if you can see a 10% reduction in lighting operation, it could be worth looking at. You'll see a payback of in around 5 years. So this example looks at a case where you've installed 17 kilowatts of LED, and the controls measure will require an investment of around £2,500. So basically that investment will be worthwhile, certainly where you're seeing reasonable levels of savings. So if you have, for example, a warehouse or somewhere that's less frequently used, putting presence detection into the aisles, having those switch off, that can potentially provide a significant reduction in lighting energy use and provide a good return on investment, even where you've already installed LED lighting. So effectively, I think it's worth a closer look if you're in that position, just to see what your own economics are for installing a control solution, but potentially it'll be worth doing even if you have very efficient light sources. And as well as that, there is some other things that need to be looked at when you are replacing lighting. So looking at the condition of your wiring, which may need to be done by a specialist. It may need to be replaced. That'll change the business case for your lighting project. Typically, what we've been looking for in terms of costs so far have been on straightforward point for point replacement. If you are looking to change the layout, you might need a revised design. The benefit of that could be a reduced number of luminaires, a reduced cost, and a reduced amount of energy consumption. Also worth making sure that your emergency lighting is up to standard and is providing adequate coverage, and that can be updated at the same time as your main lighting project. And as we've mentioned previously, the case is getting stronger and stronger for replacing all lighting, but if you have areas which have very infrequent use, such as storage rooms or areas like that, they may already have minimal lighting costs, so it's worth just bearing that in mind as well. Okay, that concludes the main part of the presentation. I'll just give some background to the Green Business Fund. So the Green Business Fund has been operated by the Carbon Trust to contribute to improved sustainability and energy efficiency. It's coming towards the end of its life, so we are running more workshops through October and November. You can see here in Aldershot, Birmingham and Exeter. The workshops are hosted by the Carbon Trust, and they help businesses understand energy consumption and identify no and low cost measures. They're aimed typically at companies with less than 50 employees. We're continuing to run a few webinars. I think this is one of the last. There may be some more coming up as well. We also have a wealth of publications which have been developed over the past few years. They're available on the website and include topics such as HVAC, carbon footprinting, renewable energy sources, and also lighting if you want more information on this area as well. We also provide energy saving tools. These help you to measure your carbon footprint, benchmark your energy use against others, and also to build the business case in particular for lighting upgrades. We still maintain the list of accredited suppliers through the Green Business Directory. This gives you the opportunity to find suppliers in a range of different technology areas. There's a lot of lighting suppliers on there, and you can search by geography to find suitable lighting suppliers. Also, the energy technology list, it's something that we manage for government. It contains a range of energy efficient products, not just in lighting, which is done by specification, but across a range of 56 technology categories, including refrigeration, boilers, motors and drives, heating, ventilation, and it can be beneficial to look at in terms of your tax benefit through purchasing equipment on this scheme. Okay, so that concludes the presentation. Just check with Susan there to see if there's any questions.
Yeah, so I think we'll just give it a minute and see if anyone has any questions, and then I'll come back to you. So we'll just go on mute for just a minute. Okay, so it doesn't look like we have any questions today. So I think you must have covered everything, James. Oh, sorry, there's one here. It says, LED lighting often appears much brighter than the equivalent fluorescent lighting. Can you advise on this?
I think part of that will be down to color temperature that we touched on earlier. So I think in essence, certainly in older schemes, I suppose LEDs may have used a higher color temperature to compensate for lower light output. Nowadays, though, in modern LEDs, it's possible to specify the exact color temperature that you prefer, so that can match in closely to existing solutions. So you could specify lower color temperatures, perhaps in around 2800 Kelvin, and that would give you a warmer white solution than some of the higher color temperatures. You would notice a difference certainly as you go towards 4500 Kelvin. It would be very bright light. The other aspect to be considered there is the glare rating of the overall lighting design. So a well-designed solution won't have too much light output from any one source, and they'll spread the light over a greater number of fittings. That'll help to reduce any aspects of glare that could come from the fittings as well. So I think it just comes down to design. Sometimes people have a preference to change the color temperature whenever they change the LED to increase that level, but it's not always the best solution.
Okay, great. So I think that's all the questions for today. So if anyone has any further questions, just feel free to send them to greenbusiness@carbontrust.com and we can answer those for you. So thank you everyone for attending, and thank you, James, for presenting today.
Thanks, Susan.